Okay, so we're on 7.3 and we are evaluating this. And again, it's a lot like 4.2. However, our triangle isn't given to us. We need to draw a triangle. And I'm going to use the word reference angle here. Did I use that with you guys already? Did I use the word reference angle or reference triangle?
Yeah.
I think when we did our unit circle, we talked about reference angles, and we talked about how, like, if I draw this like coordinate plane and XY axis, we would say, okay, well, we're going like 30 degrees backwards from 180, or we're going like 45 degrees forward from 180. Those are our reference angles. Another word we use for reference angles is bow tie angles, because when I draw a reference angle in each quadrant, it looks like a big bow tie, okay? Whenever we draw these triangles, my base of the triangle is on the x-axis, and the angle that I'm looking at is coming from the origin. So my theta is down here, and then my 90-degree angle is on the x-axis. So that's my reference triangle in quadrant 1. Pretty self-explanatory. When I get into quadrant 2, it's still got its base on the x-axis, but now it's going up into the second quadrant. Theta is still down by the origin, and my 90-degree is still on the x-axis. Now, I'm sure as you can start picturing, as I draw more of these, it's going to look like a little bow tie on this paper. So I've got, my base is still on the x-axis, my theta is down by the origin. They don't have to line up nicely, but the basic shape here is this bow tie shape. So when I am doing these next few problems, I'm going to ask that we make like a bow tie angle or a bow tie triangle in each of these cases. If it makes you happy, you can also call it a butterfly angle. That's what they look like. Okay. I drew 4 of these really carefully so that the next couple of problems, we're just going to draw one of them. But do notice every single one of these had a side touching the x-axis. Do any of them have sides touching the y-axis? Never, never, never draw me a side touching the y-axis. Okay. So when I go to this picture over here, I cannot draw a triangle that has this big of an angle, right? I'm just going to draw a reference triangle where it's based on the x-axis. Its side goes through the terminal side where that point is. And then its third side is perpendicular to that x-axis. So I've got this little triangle right here. Let me get rid of some of those extra ones. I've got my 90-degree here, and my theta is down by the origin. And because it lines up nicely with this point is at -3, -4. I know what my horizontal and my vertical distance are. What's my horizontal distance? -3. I went to the left 3 units. I went over -3. My x is my horizontal distance, and then my y is my vertical distance. So my y is -4. Once I have this little triangle labeled, I can go opposite adjacent hypotenuse, and I can also figure out what that hypotenuse side is going to be. How do I find that hypotenuse side? Good. Pythagorean theorem, a squared plus b squared equals c squared. Now, I don't know if I mentioned in your class, but do you see how I have negative sides on this triangle? That's okay because we're in like a coordinate plane. So because I'm in the third quadrant, of course my horizontal distance is negative. Of course my vertical distance is negative. However, my hypotenuse is always, 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 always positive. Okay, so I'm going to do my a squared equals b squared, or a squared plus b squared equals c squared over to the side. You don't necessarily need those parentheses, but you do need to know that -3 squared is not -9, it's +9, and -4 squared is not -16, it's +16. 9 plus 16 is 25, and then so C is just 5. Now that I have my whole triangle labeled, can you find sine, cosine, tan, cosecant, secant, cotangent? Yeah. All right, ready, go. Make sure to keep your negatives with you. So if your side has a negative, that trig function is in itself negative as well. Which of these trig functions is negative? Which ones are negative?
Sine, cosine, and the.
Good, sine and cosine, and then they're reciprocals, cosecant and secant. Very good. Which means that my only positive ones are tan and cotangent. Interesting. Okay, we maybe get to that today, we maybe get to that tomorrow, but that is an interesting thought that we're gonna find a pattern with. Holly's already over me, sorry. That's all we're doing. Does that look not like just what we were just doing a minute ago?
Yeah.
Actually, I don't know what that sentence was. That looks just like what we were doing in 4.2. Okay, we're gonna do another one like that, and then we got two more that are again very similar, but a slightly different setup.
Yeah, it's like dealing with ions.
No, that's a kid on my team. She left her water at practice. I got a fake Stanley, this little Contigo coffee mug set.
It was nice.
Contigo is very nice. It is a great coffee cup. I don't know if I'd ever drink water out of this, but it is a great coffee cup. I'm not a big ice.
You like what correct guys?
Smart. Alright, so I drew my triangle in the fourth quadrant. Do you see how I'm still on the x-axis? Does everybody have their triangle on the x-axis? What's my, let's do it this way. I'm gonna say, what's my opposite side gonna be? Is it gonna be 3 or -2? -2. What's my adjacent side gonna be? 3, very good. And then can you find my hypotenuse? Good, go do your Pythagorean theorem. Yeah. Good, my 3 is that horizontal distance, because x is your left and right distance. And then your 2 is your y, so that's your up and down. If you can simplify the radical, do it. If you can't, leave it unsimplified, that's okay. Once you find that hypotenuse, that C, go ahead and find all of your trig functions. Do not forget to rationalize. There are my answers when you're done. Check it. Any questions yet? Okay. The next two are super similar, so let's look at those together. At least the setup. On these last ones, I gave you a picture and we just drew our triangle on the picture. Letter B is just words explaining the same thing that we just saw. It says point P is on the terminal side of theta in standard position. Okay, pause. So remember when I hear standard position, I'm going to do my XY axis. And then if you remember, the terminal side is the side that rotates around. My initial side is always at positive X, but my terminal side is the one that goes around. And it says that it goes through the point 2, -2. What quadrant is 2, -2 going to be in? 4. Good. So I'm going to put a point. I truly don't care where that point is. I don't care how you draw your triangle, as long as we know that this is at the point 2, -2. And I'm going to draw my triangle. Is that right? How I drew my triangle there? No, why? What's wrong with that? On the y-axis, where does it need to be? On the x-axis. That's good. Which distance is my opposite here? -2, and what's my adjacent? 2. All right, I'm gonna be quiet. I want you to finish doing this one. When you get done with this, see if you can do the next one as well. You can do the next one as well.
So when we do HOA, and you're doing the opposite of where the angle is,
Opposite of where the angle is,
okay.
which in this standard position is gonna be your Y value every time. Alright, I've got A on the board, double check that. Do not forget to simplify your radical, rationalize your fraction, and then simplify that fraction.
For the bottom one, do you not?
Wait, how'd you get to? There's one.
So two root two times root two is gonna be two root four, which is two times two, which is four. All right, any other questions? Okay, when you're done with letter A, go scroll over to letter B, see if you can draw it, see if you can set it up, see if you can find the hypotenuse, see if you can find your trig functions. Oops, sorry. And I didn't put work out for my Pythagorean theorem, but are we okay with that? Okay. Can we keep going? I'll leave it up there for 1 second if you're still looking. The reason I wanted to do this today is I think it's a good practice of what we were doing in 4.2. And we're doing problems like that on the quiz tomorrow. So these, looking at a picture, finding the missing side, doing sine, cosine, tangent is what you're getting quizzed over. So I just wanted to do a few more practice like that. Okay. Now the next part I am also going to put on the quiz tomorrow. I know it's a brand new skill, but I promise it's easy. Can we move on to the next part? Okay. Number 2 says find one positive and negative, and that word says coterminal. Think of it as 2 separate words, coterminal. If you remember, we were just talking about terminal and sides, and those are the sides of the shape that are like kind of out in the main space, right? They're in one of the quadrants. It's in quadrant 2, it's in quadrant 4. The initial side is always that positive x-axis, and we would loop all the way around to get to that side. Positive x-axis, and I would loop around to get to that terminal side. A coterminal angle basically is like another name for the exact same angle. It's if any of you have like a name on Power School that is not the name that you go by, or maybe your mom calls you something silly and different, right? It's still you, but it goes by different names. That's what I mean by coterminal. And we're gonna do a positive and a negative. So let's draw our angle to start. The first one's at 100. What quadrant is 100 gonna be in? The second quadrant, good. Here's my initial side on that positive x-axis, and 100 is somewhere in here. I don't need it to be super exact. We're not doing protractors. As long as it's somewhere in that second quadrant, and we're gonna draw a little arrow, and we're gonna label it 100. I think when we first started learning about this, I told you we started positive x-axis and we always go counterclockwise. And I don't remember if it was this class or the other class. Someone was like, well, why don't we go clockwise? And I just was like, well, we just don't. That's just not how it works here, which is not a great answer, but that's just how they decided this system is going to work. Right now, though, we are going to go backwards. If I go backwards, though, I'm going to be going in the negative direction. So I'm going a negative amount of degrees to get to that 100. How many degrees am I going? 260. What have you get 260, Chase? 360 subtracted from that 100. I want this to be negative 260, so I want you to do 100 minus 360. And that gives us 260. Every single time we're going to do the angle given to you minus 360. Every single time. That's one of the coterminal angles. That's your negative one. Now your positive one, this gets a little trippy. So everybody look at the board for 1 second. We're going to go all the way around the circle. And then we're going to go to that 100 degrees. Okay, how much is if I go all the way around the circle? And what if I go all the way around and to that extra mark? 460, how'd we get that? 100 plus 360. That is all you're doing on these coterminal angles. You're going to take the angle given to you, you're going to minus 360, you're going to add 360. That's it. We have the normal angle direction, we go the opposite way to make it negative, and then we go all the way around once and a little bit more. Technically, you could add and subtract 360 all day. Like we could keep adding and subtracting 360, and that would still be coterminal angles. I don't need 5 of these though, I only need 2. Okay, so when I see coterminal, we are going to do that number plus and minus 360. Now, what happens if it's in radians? What's the same thing as adding or subtracting 360 in radians? Not just 5. How many pies is equal to 360? 2 pi. So we could also take it, if you look at letter B, they gave it to us in radians. I can still do radians. We're gonna have to do maybe a little bit of fraction work. I think the hardest part right now is graphing it. Which quadrant is 2 pi over 7 gonna be in? Not the fourth. Remember, it goes 0, pi over 2, pi. Is 2 pi over 7 more than 1 pi? No. If you don't like it, get rid of the pi. Is 2 7s more than 1? No. Is 2 7s more than 1/2? No. It's somewhere in this first quadrant. 2 7s is just somewhere in this first quadrant. So I'm gonna say 2 pi over 7 is just somewhere in that first quadrant. Now I have to add and subtract 360. I don't care which order you do it in. Let's minus just because there's less lines on here right now. If I'm gonna minus it, I'm gonna do 2 pi over 7 minus 2 pi. The hardest part here is that you just need to get like denominators. So I need to make 2 pi as something over 7, something pi over 7. 14, very good. 14 pi over 7. And then if you remember how fractions work, we just worry about the numerators. We say 2 pi minus 14 pi. What's that going to be? Negative 12 pi over 7. So that purple angle is negative 12 pi over 7. We also need the positive direction, so we minus 360. Now we want to add 360 to go around double. So we're going to do 2 pi over 7 plus 2 pi. Again, go around and a little bit more. I guess I can go outside around. We just said that 2 pi is the same thing as 14 pi over 7. So what's 2 pi plus 14 pi over 7? 16 pi over 7. Very good. That's all it is. All right, last example we've got has this negative 150. So we can do a couple different things for this. Let's still graph it. Let's graph our negative 150. If I'm going the negative direction 150, what quadrant is that going to be in? The third quadrant. Negative 150. And just to keep this standard, we're going to add 360 to this number. We're going to minus 360 from this number. When we minus 360 from this number, we're actually going around the twice that time. So it's a little bit different than before, but I just want to keep in your head when you see coterminal, add 360 minus 360. So if I do negative 150 minus 360, who knows what I end up with? Negative 510. Now when I add 360, because I'm adding to a negative angle, I'm going to end up just getting a positive angle that's going to be less than 360. So negative 150 plus 360. Is that 210? Yeah. Okay, awesome. Let's look at number 3. We still got a few minutes. All that I'm doing now is definitely not on your quiz. This is kind of preparing us for what I want to do after your quiz, but we still have a few minutes, so I'd rather get a little ahead. Anybody have any questions up to this point? Are coterminal angles on your quiz tomorrow? Yes. Know how to do this. Can you use a calculator on your quiz tomorrow?
Yeah.
Yes, so bring one. I have a few, but bring one. Okay, this says tell the sign of the sine, cosine, tangent of an angle given in any interval, okay? So this first one says between pi over 2 and pi. So I'm gonna look at my quadrants. What quadrant is in between pi over 2 and pi? What quadrant is between pi over 2 and pi? Not the first one, 2. We're talking about everything in quadrant 2. 0 to pi over 2 is first quadrant, pi over 2 to pi is the second, pi to 3 pi over 2 is the third, and then 3 pi over 2 to 2 pi is the fourth. So we're looking in this quadrant. And actually, let me just take this down. Looking at our unit circle, we know which is your sign. Is it your X or your Y value? Y value. What are my Y's in quadrant 2? What's their sign? They're all positive, right? My sign is always my Y value. And if you look in that first or in that second quadrant, all my Y's are positive numbers. So no matter what I'm doing, whatever angle, it will have a positive sign. What about cosine? Those are all negative. We remember our ordered pairs go negative, positive. Since my cosine is that X, all my cosines are negative. And remember, tangent is Y divided by X. I don't care what these numbers are. It's going to be a negative because a positive divided by a negative is a negative. Okay. Let's look at that next one. I've got pi to 3 pi over 2. Third quadrant. So now I'm just going to use the same picture. I'm just going to do it in this purple color. They're both negative, right? Both my sine and cosine are negative in that third quadrant. So what does that make sine? Sine is negative. What about cosine? Negative. And then tangent. If tangent is Y divided by X, what's a negative divided by a negative? A positive. Hey, we're gonna make a little, I don't know, new rule, I guess. What was positive in quadrant 2? What did we say? Which one of the trig functions is positive in quadrant 2? My sine, right? What did we say was positive in quadrant 3? Tan. Let's think about the first quadrant. What's positive in this first quadrant? Both of them, sine and cosine. Will tangent be positive too if I divide a positive sine by a positive cosine? Yeah. Good, so they are all positive in quadrant 1. And then in quadrant 4, what's positive? Which one's positive, X or Y? X, and so that means cosine's positive. If sine's negative, tangent will still be negative because a negative divided by a positive will be a negative, which means only cosine is positive in the fourth quadrant. This is a shortcut that we are going to use from now on. I don't know if you have friends in trig right now and have heard all students take calculus. Is that something you've heard any of your friends say yet? We must be a little bit ahead of them because normally you guys have. That is a shortcut that I actually want you to get your unit circle out right now and write on your unit circle. I don't think I have it attached here. But on quadrant 1, I want you to write A or all. A or all on quadrant 1. On quadrant 2, I want you to write X or sine. Let's see if I have it on last week. All right, here. Actually, on the first quadrant, we're writing all. On the second one, we're writing sine. What are we writing on the third one? Tan, T or tan. And then on the last one, we say cosine. So the mnemonic we use to memorize this is all students take calculus and all students take calculus. So on the next problems that we are not gonna get into today, I'm gonna start by doing a little quadrant and writing ASTC to help me decide what quadrant I'm gonna be in. Okay, so all you really need to do on your unit circle, you've got a really pretty one that we're still using as reference that we're knowing. All sine tan cos. All sine tan cos. We don't have time to like use that yet, but I'll remind you about it after we do our quiz tomorrow. So my plan is to come in, take the quiz, learn some notes afterwards. I don't think we'll finish enough to have homework on 4.3 yet. But we're getting close and we're gonna spend Monday kind of reviewing and practicing and doing more of this stuff. Okay, everyone good? All right, you got a few extra minutes.